a couple of more topics and then some troubleshooting, because when we started out last week we talked about we would do the troubleshooting as we did the individual concepts or individual technologies that we have. This one is Perform Network. We want to manage the network, and obviously we want to do everything as centralized, as easy, as automated as possible when we do these things. You're going to have situations. We had situations that, what's going on? Why is the network so slow? What kind of monitoring do we have? We had an incident where us at Roanoke were managing our bosses at the headquarters activity, and midnight, middle of the night, 2 o'clock, 3 o'clock in the morning, 1 o'clock in the morning, full pipe, full bandwidth outbound. Pretty unusual. And they say, oh, well, it's the day before finals, all the students are doing stuff. Well, that ain't happening. What had happened, kind of a long story, but what had happened is on the day before, the webmaster who worked from home had wanted to update the website and had called the network administrator and said, hey, I need to do an FTP upload. So the the network administrator opened a hole in the firewall, started the FTP server, got this hole going out in the firewall. Anonymous access, why that was, I have no idea. Anonymous access means that we're not got any security on it. Anonymous access, webmaster does his thing, uploads the change, we're done. Network administrator gets busy, forgets about a hole in firewall. User in Germany doing a scan finds an FTP port open, finds an anonymous access, uploads his movie, not a porn movie, just a movie, to that hard drive, and then shares that location with all of his friends so that they can download the movie. Things that can happen. How did we find that? By network management, network observation going there. SNMP was the protocol that we use for that. So network management, practice of administering network, computer networks. Nothing really, I guess, earth-shattering about that statement, but the common goals here are to ensure that the network supports the organization's business requirements. Is it available? Back to the old CIA, confidentiality, integrity. Availability becomes a high-performing services to users that depend on the network for their job. We want to save time and money. And where are we going to save time and money? Because we're going to centralize, automate, use the tools that we can find are available to us in order to make the information available quicker and in a more usable format, and be able to do analysis. Improved efficiency and security, reduce downtime, improve system performance. All of the things that, all good terms that we want to use. In order to do these things, we're going to use 3 technologies. One is SNMP, which can be used to monitor as well as to modify the network host, the network stations that we do there. Syslog, the Syslog servers are going to allow us to take the logs off of the server, off of the device, off of the router, or off of the switch, and save them onto a workstation, save them onto a disk, save them to a location where we can do analysis. Quality of service, and one of the things about quality of service is we may or may not indeed do a discussion, and I've got a packet tracer lab for you for quality of service, so that you get an idea of what it is, how to configure it, just hopefully for repetition. And I'll do a demo of it also, and then you can have a lab, a little bit different lab. SNMP, Simple Network Management Protocol, and I have to say that very carefully because SNMP versus SMTP, to me they sound quite a bit alike. SMTP, Simple Mail Transfer Protocol, is sending email, port 25. This one uses UDP ports 161 and 162. It can be used to monitor as well as to modify configurations. It includes the SNMP managers, the NMS, the network management station that we saw in the question. That's a computer that we use to request and collect the information. We're going to have an SNMP agent, which is a software installed on the network devices, and then we're going to have a management information base, which the MIB is going to be the items that we can do and the way that we identify them. And when we look at the MIB, it's just going to be a series of numbers that identifies a device as, maybe a Cisco gigabit interface, a CPU, this or that, or a disk. Different things are in the management information base. So the whole thing, we have the SNMP manager, which is the computer. The agents are on the devices, and then the MIB, the management information base, has the OIDs, the object identifiers, listed in it so that we can pick out, identify individual resources. I want to look at, or try to anyway, to look at an SNMP software. And the SNMP software that we're going to look at here is one called, Control-Alt-Delete here. So it is one called PRTG. There is an open source one called MRTG, a little bit more difficult to manage. This is they have a freeware version. You get 100 sensors on this, which is the first time I ever used it. I think you got, when I go into this, the front page here, I got 10 that are down, 0 acknowledged here. I have some warnings, some up, some pause, the usual. So I get notifications, all sensors, and then current alarms. 10 are down, and I can view the alarms, what's going on with my network. As I manage, or can I go back here? First of all, I'll go back to the home here. It says updates available. I haven't done that yet. I will, because every time I install an update, it messes things up. My browser says it needs an update. I tried to update it, and it wouldn't for whatever reason. But new alarms, I have 4 new log entries, 184 log entries. And here's the 10 are down, the warnings, and then the goods, the ones that are up, the greens. We can go into here and look at our devices. I've got a local probe here, disk free, and if I look at these things, it tells me the live data, 2 days worth, and you'll notice that there are big holes in this because I only turn this on when I do a demo. So what is the availability? And this would be, as long as the device is running, this would be a constant monitoring, up to a year's worth of data. We have historical data here, and we can specify the date range. What's the advantage of this? You can see trends when we do this. We used to use, at Blue Ridge, we used Citrix server, Citrix database, a Citrix farm. We had to have Citrix clients on the devices in order to connect to it. So when I've told you about the DHCP and the counselors that would come into the afternoons, and those numbers tend to change, tend to grow always. And, bureaucracy will always tend to get a little bit bigger and grow and grow and grow. The mission grew, the numbers grew, so we had to keep track of the clients. How many clients were active at any time? What's the maximum number of clients? Monitor that so that when we start running out of licenses, we can go to management and say, hey, we need to buy some more of these things, or some of these guys are not going to be able to do their job. This is the kind of things that you can do with it. The discs here and then the reds here, these come up and come down. I had a brand new one that didn't work this morning. I had been monitoring the SNMP load, and it says it's not here, not working on my machine here. 30 days, 365 days. You can see that it had worked, so probably a firewall issue. I didn't have time to look at it when we do that. The 2 days here is not going to show me anything. Processors 2, it's just showing, and we'll go to live data. It's showing me that it is not talking to it. So what can we do? CPU load, no response. Check firewalls, routing, SNMP settings of the device, the IPs, and all those other things. Probably not this device because other things are working with it. So then I would go back to the specifics, and I think Windows is not real wild about using SNMP. They have the Windows management system, the WIMS, that they like to use. But it obviously is talking to it because I can ping it. It's telling me about my certificates. The thing that we would be concerned with, this down here is a router. This actually is a router that is running on this thing. That tells me about the certificates. The CPU load on this one, it's going to be like minuscule because I'm not really doing anything with it. And the two different areas here, we're all the way up to 2% load, but you can hopefully get the idea. 365 days, again, only when doing demos do I use these things. You get the idea of what you can do in order to monitor your network. Why would we want to do that? What are the trends that are going on? And here the bandwidth. We used to monitor each room, the data traffic for each room, so that you can see if somebody is abusing their privileges from one to the other. I want to minimize this because the next thing we're going to look at is stuff on the router when we do that. So we have the SNMP managers. That's the PRTG, the MRTG, the other software. There are others obviously available for that. The agent is configured on the device, and on the Windows machine I had to go in and turn on the SNMP server. We got to do that on the other devices too. The routers here let me do this, and I got to config here, and let's do SNMP and then question mark here. Let's do SNMP question mark without the space, and we get dash server, and I have an incomplete command. So what are the things that can be configured on the SNMP server? Community here, enable the SNMP, the community string. I want to look at those. The community string is the quote security unquote for this thing. It's going to be clear text. We have two communities, typically a read-only community and a read-write. The read-only here, the community string, let's say the public and private is going to be the strings, that word here, and then whether it's we'll call it public. And then we would say that it is a RO read-only, RW read-write. Read-only means that we're going to accept information from it. Read-write means that we can accept information from it and send information to the device. Maybe not such a great idea. Again, we'll look at a packet tracer. You can see the community string clearly, the SNMP server. So SNMP server, we can activate here, and we can configure the other thing, trap, authentication, the link, fine tune, let's see, link assign SNMP traps to the IET, the trap, timeout, trap source. The traps are what we're going to, so where are we going to get what's going to be the trap source, fast Ethernet, and then the interface number, where the traps, where the information going to come from to with these things. So configurations of the SNMP server, and then SNMP has the MIB commands, the management information based commands, the community map, notification persist, target, those other things, and then the IF MIB when we do that, and we do trap, throttle, disable, sublinks, and on down the line. Lots of different configurations. We kind of make these things, and the reason I like to go and look at these is we sometimes make these out to be, okay, there's only 3 commands. There's a number of configurations that are available in these things. The SNMP messages, basically 2 forms. One's a trap, one's an inform, and the trap is initiated by the agent. The inform acknowledge the trap. So the trap is going to be, and we saw that there was a trap on that, it's going to be initiated by the agent. We had the trap command to do that, which will only send us the information unacknowledged. The inform started with SNMP v2 version 2, and we have 3 versions, 1, 2, and 3. Acknowledge with the trap, and it acknowledges the trap. Same information, but we get an acknowledgement instead of a fire and forget sort of thing. The get, request data. The get next, request the next available. The get bulk, multiple iterations, and then the response. The agents reply to get and set messages. The get messages get information. The set is we're going to send commands or send information, configuration information to the device itself. Request to change the value of a variable is going to be the set. SNMP notifications that we have sent by the agents to establish communications with the network management system. When an event requires attention is encountered, the router has failed, we'll get messages. We can configure these things to send us notifications when we need them and the types of notifications that we need. It's kind of, a wake up. Yeah, we have a problem here. Let me send this. Depends on how sophisticated the management system is also. And what's going to happen is we'll configure thresholds, and then when that happens, the management system, the software, will send a notification to us. 2 types of notification messages are sent are the trap, the fire and forget. SNMP issues, an agent issues a trap message, the message transmitted to the IP address of the management system. No error recovery is going to be in here. And some of the, if we went through a number of other, looked at the configuration possibilities on that router, the IP address of the NMS would be one of those things. Why do we want to do that? Who can see this stuff? Anybody that's on the network. Who can see the password? Anybody that can get a hold of the traffic. Inform message has an acknowledgement mechanism that's associated with it. So we get some acknowledgments from it. Acknowledges the receipt of version 2 and version 3. The agent retransmits the inform message if there is no acknowledgement for the information. The database is maintained by the SNMP agent, and it's going to be called the MIB, the Management Information Base. Stores the information in variables, and the values in the MIB variables are used by the management system to monitor and control the device, are identified as object IDs, OIDs, and it's a hierarchical structure that we use for those things, specified by RFC and Cisco proprietary standards. When we look at this thing, we have a MIB variable, CPU utilization 1.3.6.1.4.1.9.2.1.58. And this is what the SNMP messages are going to look like when we see them. Let me see if I can get this one open. And if we look at SNMP here, we have something that looks like that. Get next request. Get next request 1.3.6.1 on down the line. Different information that it's looking for. If we look into the SNMP protocol here, and this is an unencrypted UDP packet, data packet, port 161, 161, and 162 are the 2 that it uses. It says community, public. That's the password. We configure it so that any network management system that's looking for that can see this data, that's looking for the community, the community string here, is going to accept that information. And we have the 2, the read-only and the read-write. Typically, public is read-only and private is read-write. Those are the defaults. That's not what they have to be. We can set whatever we want. I guess the unfortunate thing here is all these are gets. There is no responses that comes up with these. But this is a version number, version 2C, and 2C is what we're using now. The community string, and then the get next request. When we do these things, the request ID, the variable bindings on down the line, and then the what we're looking for, the object name, and this is This is an ISO object name. So this is what the object names look like. They're obviously, computers like numbers, we like names. This would be associated with a something here. It's not the 58 one that we had up here, but it would be associated with a piece of equipment. This one, the MIB variable 1, 0.3, 0.6, 0.1, 0.4, 0.1, 0.9 Cisco, and then it keeps going on down, and eventually what this represents is the CPU utilization on a device. So it's a long sequence of numbers. We have the series here that we can see the get response request on down the line. These are, the get response here. What do we have, and what is the information that's available to these devices? SNMP versions, there are 3, 1, 2, and 3. Two important features supported by SNMP are IPv4 supported by all versions, and then security. We have the SNMP versions 1 and version 2 support a password mechanism. And you saw the password mechanism. I wanted you to see that. Yes, that's the security that's available to it. That if I know the community string, I can get the information. How can I get the community string? If I can sniff the network. So one of the things that would help us to keep users from sniffing the network would be to use switches, because the information or the data only goes to the intended MAC address based on the ARP protocol that uses the IP address to find the MAC address. So it's only going to go directly. We had a situation that our bosses one time decided that we didn't need to monitor our network anymore. And we decided we did need to monitor our network anymore. So in order to find, because they changed the community string, in order to do that, we just put a hub into the network, into the data stream for a few seconds, probably about 2 minutes, a minute and a half, something like that. And then we did a sniff on the hub. We got all the traffic, found the community string, went back and modified our NMS, our network management system, our host, to look for that. And then we were able to monitor the network again. So can you, can't you, the things that you can do. Not a real great, I guess, vote of confidence for that type of security. Acts as a password, but it's clear text. It could be, and we have MD5 weak for version 2 and version 3, and DES is going to be used in version 3. The two community types, the read-only community to get messages, and the read-write community, used in the get and the set. SNMP agent processes the get or set commands. The SNMP agent, the software that we run on our device, our Windows machine, our Mac, or our Linux machine, in order to do those things, to get those things. Version 2C, additional types, in addition to SNMP1, the additional SNMP1, and it was before me, but it was a basic failure. SNMP version 2 has been around for a long time, but it has the read-only and the read-write, and we can do access control lists. Access control lists we'll do in security, but when we do there, think about what can I do with this thing in order to protect my network, send information that I want where it needs to be and only where it needs to be. And that's a big thing that access control lists are going to do for us. Filtering the packets. Where can we go with advanced features of version 2? Bulk retrieval, huge volumes of information, error reporting. Version 1, one type of error code. Version 2, multiple error codes when we have these things. And then exception reporting. Different types of exceptions, such as no such instance, no such object, which helps when we're trying to add things, that we get something that says, hey, that object doesn't exist, that instance doesn't exist. It's kind of like the error message I'm getting, that instance doesn't exist. So let's go back and check some things to see if we can figure out what's going on with this. Why am I not getting version 3 actually has security. It replaces the community string with a password, with the authentication. The message integrity identifies whether it's on-the-go modification. The message integrity hashing. And anytime they say integrity, think hashing. And we looked at what a hash does. Hashing software, and I think that in the share that particular hashing program, if you want to play with it, is there what a hash does for you. And it actually, you can use it to hash your files. Did somebody change a file? What goes on here? Encryption is optional. Integrity is going to be the default for these things. So SNMP version 3 by default is going to check the integrity of the message, and did it change en route from one to the other. Encryption is going to be optional, and authentication is going to be optional with these things. So the no auth, no authentication here is the message integrity, the default. Auth, and how we configure it, SNMP version 3, auth, message integrity, and authentication. And then privacy, we're going to have message integrity, authentication, and encryption with the SNMP version 3. Let's see, the configuration, enable the SNMP agent, SNMP server, community string. We looked at that. Configure an ACL, configure the ACL reference if we're going to use an access control list. Sets it to a read-only or a read-write, the community string, and we looked at that SNMP server, community, read-only, read-write, IPv6. A couple of other things that were available in it, so we can go back and look at that. So we have the SNMP server, community, and then the community, and let's say this is going to be the public, and then what we can have, we either specified a read-only or read-write. IPv6 view, this one's an older one. It doesn't have the access control list option, and each of them is going to be a little bit different on the options that are available. Restrict this community to a named MIB view. So we have the configurations on the device itself, the agent. Here, and then document the device location, SNMP server location. These are just going to be where they are. The contact, SNMP server, contact, who to contact. Remember, some of these things you may not want to put into there. The SNMP, the contact may give too much information, more than we want. It traps and informs the host name, the IP address, the informs version that we're going to use. Version 3 doesn't include the community string because it's got actual real security involved in it. So that does the SNMP. The next is syslog, and I think we can do it before we do our break, and we should be able to. What I'm doing right now is starting my syslog server, my Kiwi free. It will go, it's up and running, and we'll go to the server here and do some, or to the router and look at the configuration. But syslog, standard for message logging. Syslog, we're going to take the messages that we normally get to the console, and that's the default logging. And you see those when you do a Control-Z, and Control-Z will save whatever config command it is and return you to the privilege exec mode. And it, you get a message that's configured from console. That is going to be a logging message that we will have. And they're kind of a pain sometimes when they split your configuration, and what you do to make that one work is you go to the line console 0, and use the logging synchronous command, so that when you do that, it'll keep the line. Syslog is a standard for message logging. It's been around a long time. Widespread use, gather logs from many different sources. Why would we want to do that? So that we can see what happened. What did one thing influence the other one? And I'll go back to cascading. And a cascading is one event causes another one or makes another one worse from one to the other. And you see that happen all the time. Maybe in a fog, that two cars have an accident, and from that we have a cascading event. Somebody slows down to look at it, and somebody hits them from behind, and the other person's texting, and they do the other one, and we get a chain reaction. So what we're really talking about here are chain reactions. That we can see what goes on, what happened first, when did it happen. And we can centralize with the syslog server, and we can also put it on a device, a physical content that we can now go back and do analysis with. The other advantage, I think, to this from a security standpoint is the last thing that a hacker does is to, if the logs aren't on the device, they can't delete them. And we now have that information someplace else in order to be able. So the events are categorized by severity. We'll look at those. Those are the trap levels, the 0 to 7. 0 being the most severe, 7 being the least severe. 7 is like Cisco devices store syslog messages internally by default. Configure to send the messages to the syslog server or other destinations that we need them to go to. So what we have, and let's go back to this guy here. When we do that, let's get out of the SNMP and let's just do logging. And logging is the command that we'll use for this. Let's see if this makes, and I can't make it go up. It's going to be down at the bottom. Logging, what are we going to use here? We have the host name or the ABCD. So we're going to do logging to 192.168.1.27 is the device that we're going to do logging to. So the next thing is logging. Lots of other information in here, filter, facility, exception, console, on down the line, but we've just told it to send our logging information to that IP address. And it's going to presume that there's going to be something there to accept it. The syslog is not going to be a TCP sort of arrangement. It's going to presume that there's going to be something there to accept the logging information that we're sending there. We can configure it to send it to someplace that doesn't exist. But in this case, the trap, and this is one of the questions that we had this morning. What level do we send? If I wanted the zeros and the 0 here, let's see, the 0 to 7, warnings, emergency severity, emergency system is unusable. And this is just my mental manipulations or odd thoughts. If it's unusable, how the heck's going to send us a message? But it's there. 0, 1 is immediate action. This is going to be alerts. 2, critical. 3, errors. 4, warnings. And you know, we may not want to see all the notifications, just the standard messages. So what we can do here is do a trap 4. And if we do that, it's then only going to send us the 4s, the 3s, the 2s, the 1s that we have with. So what I'm going to do is go back into this thing and do logging trap, and I'm going to do 7 so that it sends us all of the information, and then Control Z here gets us out, and it sends us back. And I did get one. I wanted to get an entry into the syslog server that we have configured for console. And what we have here, it sent me a message that says, hey, logging to host 127.1.1.27 started, command line initiated. It sent me a message. When I did the 4, it didn't send me that message. But now we have up here at the date, the time, that it's an info message, local 7 the priority, local 7 info. 7's not the priority for this. Info is the priority for this. The host name, where did it come from, and then what's the message? And the message here is just logging to host. So we can get the messages off of the device and on to a hard drive. Cisco devices send the system messages, the debug output, to the local logging process debug. We actually see it. The debug would allow us to go in here and see some of what goes on. And most of these messages down here that are in this thing actually are debug messages. I did that one time just to get a whole bunch of stuff, because if you look at the debug on the device, on the monitor, you just keep rolling up depending on how much you're debugging. This allows us to now get it into a an area that we can actually go back and read what goes on with these things. This was a routing process that was going on, routed via for these things, and I think that probably may have been a debug IP rip or something like that. So it allows us, if we're doing the debug, to be able to go back and at our leisure, instead of trying to follow everything that's changing rapidly going the way up, allows us to record that and go back and do analysis with it. Manually configure the logging process to allow the message to be sent to a different destination. syslog, internal buffer, TFTP, wherever we need it to go. The logging commands. And logging synchronous, again, is one of those things that, and it may not have happened to you, it's happened to me a lot of times, that if you don't have it configured, you do the Control Z, it takes a few seconds, and then you start on your next command. And right in the middle of the command, you get the notification that it was configured from the console, and it stops whatever you're doing, splits that command in half. Logging synchronous will keep your commands on the same line, so you can just keep going, keep logging with it. It's one of those things. Two things that you may want to use in real life and even in lab life while you're working on things. And two things that I usually do if I'm going to do much is to go in and go to line con 0 and do logging synchronous. The other one is in the config, in the global configuration mode, no IP domain lookup. No IP domain lookup when we make typos, and it kind of goes churns and churns and churns. Control Shift 6 all together is the break sequence. But what happens when we make a typo, the system's trying to resolve that to a fully qualified domain name. It's trying to resolve that typo to an IP address. It takes a few minutes, a few seconds, a few minutes, minute maybe and a half or so for that to time out. No IP domain lookup, it won't try to look that up, so you will avoid that. But also, if you need to use a DNS server, it's not going to look those up either. But we did this: identify syslog collector, set the syslog server IP. When we did that, logging, limit the size of the syslog. These are commands that we can use in this thing. Logging, monitor level, limits the messages logged by the console by security level. In our cases, this was logging trap. Image here, what are we going to do? The syslog. Syslog messages are sent to the syslog server. The syslog server can be configured to send, depending on the sophistication of the server. I can't do that with my free one, but with paid ones, I'm sure I could. To send alerts to the administrator. And we can set, what level of alert we want to see. If we want to see alerts, if we get maybe a level 1 or a level 2, or certainly we want to see a level 0. Inoperable. The alert levels table here, it shows up a couple of times in the presentations, did in the last ones too. If you come up with a good acronym to remember this, would you let me know? I never have. The EACEE appears a couple of times up here, and then I guess the NID at the bottom here, but I've never really been able to remember this. Not saying that you'll need to remember it, you need to have an idea of what it is. Probably the top levels, and I think that you'll get into the how would you configure it. Like if we wanted the 4s, the 3s, the 2s, the 1, we did trap, and then the level was 4, so it will give us 4 in everything that is more severe. The logging types that we have with these are the Cisco routers, these 5 different logging types. They're the console logging, logs to the console port, terminal logging, to the console logging, the VTY lines. And you have to, if you want to see that on the VTY lines, you have to set terminal logging, because it's by default it's going to go to the console. If you want to see it on the terminal, and the terminals, typically you're not going to see anything unless you do terminal logging. Buffered logging uses the router's RAM to store the log messages. The syslog server we talked about, looked at the external syslog server to do this. And SNMP trap logging, we can use the SNMP agent in order to do that. Allows the SNMP traps to send log messages to an external SNMP server. So, number of ways to do those.